Good day, students. Welcome to video lecture episode 4. We're still in chapter 15, section 1. Yesterday we finished with atmospheric pressure. Now we're going to be moving to slide 46, which is titled Temperature and Atmospheric Layers. So the sun is the source of most of the energy on this planet we live, called Earth. Before it reaches Earth's surface, energy from the sun must pass through the atmosphere, because remember, the atmosphere is a protective layer. Now, because some layers contain gases that easily absorb the sun's energy, while other layers do not, the various layers have different temperatures as a result. Now, this was illustrated in your text in a visual image, but I believe I also have the same or a similar image posted here on slide 47, so you can look at that referring to that variation. On slide 48, I have a little bit larger view of that image, which may help some of you. And as you can notice in there, you can see the troposphere, the stratosphere, the mesosphere, and the thermosphere. And it indicates both the height in kilometers from the Earth's surface as well as in miles. Now notice there are places, the kind of transition phases, so to speak, between those phases, the tropopause, between the troposphere and the stratopause, which is between the stratosphere and the mesopause, which is between the mesosphere and the thermosphere. Now let's move to slide 49, continuing this discussion about temperature in the atmospheric layers. Molecules that make up air in the troposphere are warmed mostly by heat from the Earth's surface. Just keep that in mind. The sun warms Earth's surface, which then warms the air above it. All right. So let's just talk about this a little bit more in connecting this context to some activities that occur on Earth. When you climb a mountain, the air at the top is usually cooler than the air at the bottom. Every kilometer you climb, the air temperature decreases by about 6.5 degrees Celsius. Pretty interesting to think about. Molecules of ozone in the stratosphere absorb some of the sun's energy. So ozone actually does a job within the stratosphere of absorbing some of the sun's energy. Energy absorbed by ozone molecules then raises the temperature, which should make obvious sense to us. Now, because more ozone molecules are in the upper portion of the stratosphere, the temperature in this layer rises with an increasing altitude. So in other words, as you go further up in this part of the atmosphere, obviously the temperature goes along with that. Now, like the troposphere, the temperature in the mesosphere decreases with altitude. In other words, so it's kind of interesting. One increases with altitude, but this one decreases with altitude. Now, the thermosphere and the exosphere are the first layers that receive the sun's rays, and we would obviously expect those places to be the warmest. Now, few molecules are in these layers, but each molecule has a great deal of energy, so temperature here are high, just like we expected. All right, let's continue moving on with our discussion. Now let's get into the ozone layer. We already talked about what ozone is, how it's made up of 3 molecules of oxygen connected together, but let's just get a little bit more knowledge about that. Now within the stratosphere, about 19 kilometers to around 48 kilometers above your head, lies an atmospheric layer called the ozone layer. And as I already just stated, ozone is made up of 3 molecules of oxygen connected together. Now although you cannot see the ozone layer, your life actually depends on it. The oxygen you breathe has 2 atoms per molecule, but an ozone molecule is made up of 3 oxygen atoms bonded together, as I've stated multiple times. Just want to make sure that's sticking in and that we remember that. Now, the ozone layer contains a high concentration of ozone, and this ozone shields you from the sun's harmful energy, kind of like the picture I have on slide 57 of Captain America with a shield. Just like a shield protects someone in battle, so our ozone protects us from the sun's harmful energy. While there's things we need from the sun, there's also things that come as a result that could be quite detrimental to our lives. Ozone absorbs most of the ultraviolet radiation. If you notice on the picture on slide 57, the one on the left, it kind of shows us where that ozone layer takes the UVB, and it takes up a good portion of the UVA as well. So we should be thankful for that. Moving into our last 2 slides for today, slides 58 and 59. On slide 58, we just talk about ultraviolet radiation, that it is one of the many types of energy that comes to Earth from the sun. Too much exposure to ultraviolet radiation can actually damage your skin and cause cancer. Now, if you look at the image on slide 58, you'll notice that there's UVA, UVB, and UVC. All right, and these are the 3 types of ultraviolet radiation that come from the sun. Now, on slide 59, where we'll stop for today, I just have a bigger picture of that same image so you can see. Now, if you look right there, you see UVC is blocked by the atmosphere. Okay, so that's good to know, and it's, if you notice, the most damaging. UVB is blocked to a great degree. I mean, we still do get some minor remnants of it, but we don't get much of it. Now, UVA, that one is the one that reaches us, of the 3, it reaches us the most because while a lot of it is absorbed, not all of it is absorbed, and it reaches the lens and the retina, so it can affect the eyes. So if you're not careful staring into the sun, there can be damage to your retinal vision. All right, ladies and gentlemen, this has been video lecture number 4. Make sure you please watch this, and if you haven't watched the other ones, please do make sure you watch those, take notes, and then submit those on Google Classroom. Have a nice day, and I look forward to seeing you guys in either office hours or in the comments below. Thank you.